Alrighty, for part 2 of test 3, there's going to be an application of exponential functions problems. So really, in order to be good at this, you really need to be able to read this type of equation. So what are the variables that this equation or function is composed of? So if you look here, the growth of a colony of bacteria can be modeled using the following function. So the key word here is growth of colony of bacteria. So the colony of bacteria, the total amount of colony of bacteria is n of t. This happens, the growth happens over time, and that's why you see t here. You need to know when a question is asking you to solve for t versus when it's asking you to solve for n of t. So in this part A that I added here, what will be the population in 5 days? If you notice, it's already giving you time. It's asking you what will be the population. You have to make the connection that it's asking you to find the output. So the only real way you could do this is straightforward. What we're going to do is just plug in 5 days for t. So n of, not t anymore, but 5 equals 75 e to the 0.025 and then 5 for time, right? And this is only true because it says in days, right? So make sure you pay attention to that. Now, because you don't have use of calculator, right, this would be all you would be required. Now, in the case that you are allowed to use calculators, then please make sure that you punch this number into the calculator and you just write exactly what it says on the calculator. Don't make anything up. Keep it super simple. Now, for part B, you're asked, how long will it take for the population to reach 200? Okay, 200, it doesn't matter, 200 million, 200,000, that's not what's important. What's important is where does that go, right? So remember, n of t is the total population, so that's why n of t is going to be replaced with 200, and then the rest is 75 e to the 0.025 t. Now it's asking for how long it will take, right? You can only get there if you solve for t. So right now you get half credit because you set it up, but now you have to actually solve for it, right? So in this case, you have to remember that the only way you can bring down the t is through the use of logarithms. In this case, you do not want to use log, because remember, you use log when you need a base of 10, a base of 7, etc., etc., etc. Here, we're going to have e. The only one that can provide you e is ln, because that has a natural base e. So make sure you remember that, right? The whole idea is you need to cancel this e so that you can bring this up, you can bring this forward. So let's get the ball rolling. Before you can even apply ln, there's some basic math, right? You have to divide 75 to both sides. You need to get everything away from t as much as possible. So in this particular case, you leave it as 200 over 75 if you do not have access to a calculator, and that's okay. So 200 divided by 75 equals e to the 0.025 t. Okay, and now the only way you could bring that down is to apply ln to both sides. I know I'm eating space down here, but it's okay. This is where people get confused, right? Oh, I don't see the base e because you didn't write it, but it doesn't matter. If you practice enough, you understand that this is base e and base e of e, right? It kind of cancels out. But before that happens, the property that you're allowed to use is ln of 200 divided by 75 equals 0.025 t ln e of e, right? So this is going to become just 1 from the properties. So now we're almost there, but we're running out of space here. So let's zoom in. So t is, let me see. What I'm going to do is I'm going to switch these over, right? So I'm going to write that here, and I'm going to write that over there. You'll see right now in just a second. 0.025 t equals ln of 200 divided by 75. And we're almost done. At this point, you just divide by 0.025 to both sides. And just so that you don't screw anything up, You just go 0.025, and then this cancels out here, and then you just write the rest, right? T equals, and then you just rewrite it. And that's it, you're done. No need to get exact numbers, all right? Now, in order to prepare for that, I'm gonna look to see if I can provide you with more of these problems here, right, for extra practice. But this is really the only type of math you need in order to get good at what we did over here. But the rest is just reading the problem, right? So you don't need all kinds of different types of problems because that's not really going to help. Just make sure you're going through the process as you're doing each problem. So just to help out one more time, before you can solve for t, we need to get rid of the 400 to both sides. This one's a little easier. It's going to be 1/2 is equal to e to the 0.20. Pause the video anytime if you need to work on the math, and then we need to apply ln to both sides. And in this case here, because you can sort of project what's going to happen, you can rewrite it like this right off the bat, right? Look at that. So I already wrote it like this because I know that this is going to become 1, and I already brought down the exponent. So then at this point, you can kind of kill a few birds with one stone, right? I mean, you could get sloppy already and start dividing both sides by 0.20, but just make sure that at the end you rewrite it. So it's going to be t, that cancels out right here, equals ln of 1/2 divided by the whole thing is 0.20, right? Don't start, this is where you just start cutting corners. What will happen on the test is people will start doing something like this, right? And they'll do something like 0.20, right? Although that may be correct, this is not something you want to do. Just make sure you just take your time and do it right, okay? All right.